Hi, I'm Carl Franklin. It's been a while since I was back here at the Blazor Train Depot, and that's mostly because I've been doing the Blazor puzzle with Jeff Fritz every week. What's the Blazor puzzle? Well, it's a weekly YouTube show where Jeff and I give you little Blazor problems to solve, and then you email us the solution, and we pick a winner every week to win a piece of useless marketing junk. We've been focusing on Blazor in .NET 8 since its release, so you might want to try your hand at some or all of the puzzles at blazorpuzzle.com. In this episode of Blazor Train, I'm going to revisit handling application state in Blazor. Now, I'm only covering Blazor web apps in .NET 8, so if you're looking for the .NET 7 version, follow this link in the top right. For this episode, you can follow along with me by reading the README file at this repo right here. Managing and persisting application state in Blazor on .NET 8 is coming up right now, right here on Blazor Train! So I'm going to start out by bringing your attention to this repo here. It's github.com/carlfranklin/AppState WM. And this has all the instructions in the code to do exactly what I'm going to show you right now. However, check this out. If you want to do the same thing, but for server render mode or auto render mode, I have two very similar repos that are tweaked ever so slightly for this scenario. But I'm going to be doing this in WebAssembly render mode. And so you can see here all of the instructions that I'm going to show you now in this video. So let's start out with this. What is application state? Well, AppState is what I call it, represents collectively all the variables, objects, lists, IEnumerables, whatever, that you keep alive in your application while in use. The default Blazor sample app templates keep all variables in code blocks inside of pages and components. And the problem with this approach is that those variables get reinitialized every time the page is navigated to or refreshed. And the key to AppState is to move it into a component that lives outside of the pages, so that variables can persist between navigations and page refreshes, and they can be shared by all pages and components. So the goals of this AppState component is that we want the UI to automatically update with binding whenever any of these properties update, and we also may want to get control when the properties update. So we're going to create a new Blazor web app called AppState WM. And now here's the key. I want to choose WebAssembly for the interactive render mode, and I also want it to be global. And I'm going to include the sample pages as well. So just take a look at that. Interactive render mode WebAssembly, interactivity location global, and include the sample pages. Now the approach we're going to take is to use a cascading component. And this is essentially an object reference that can be accessed by any component in the render tree below where it is defined. If we want all pages and components to have access to it, we can wrap it around the router in routes.razor. But I'm getting ahead of myself. Let's just run this and observe the default behavior. All right, so we navigate to the counter page and update the counter and go home or to the weather page and then back to the counter, and the counter is back at 0. Let's take a look at the counter page. So the reason for this is that this variable, current count, is defined inside of this component, right? So every time the component is navigated to, it is reinitialized, and this is reset to 0. So one goal is to move things like this outside of this component into another component which can maintain its state during the entire application session. So to fix this, we're going to add a component to the client project over here. And I'm going to call it Cascading AppState.Razor. And here's the code. So all we're doing for markup is we're showing the child content. In other words, whatever this component is wrapped around, we can access this render fragment, child content, and just simply display it. So to illustrate this, I'm going to go to routes.razor, and I'm going to simply say I want a cascading AppState around the entire router. And if you know what the router is, this is what defines what page is showing. It looks through all of the components for those page directives, right? Like counter has a page directive right there. It says, oh, this is routable. And so if the URL matches that route, the router says in this found here, I want to show a route view. Here's the default layout, and whatever that routed view is, in this case, the counter, it's going to show it. And then, of course, we have this focus on navigate thing, which they introduced recently. This just means that if there's an H1 tag, set focus to it. So that comes into focus. This is just optional stuff. The real important thing here is the cascading AppState around it. All right, so let's go back to that. And let's look at this, render fragment. What the heck is a render fragment? Well, a render fragment represents a chunk of Razor markup that can then be rendered by the component. Razor components can capture their child content as a render fragment and render that content as part of the component rendering. To capture child content, we're doing this. We're defining a component parameter of type render fragment. We're naming it child content. And that tells the system that child content is everything in the render tree below this component. So let's look at the properties we've got here, message and count. Now the way I've got this set up is I've got backing fields for each of these, and the get just simply returns the backing field, but the set, I have this option to force a re-render by calling state has changed. Now if you don't do this, then what's the point? I mean, you changed it, but now everywhere where this message property is bound to the UI, it won't update unless you do this state has changed. So this is a nice little pattern for allowing the Blazor component system to update and re-render the page whenever any of these properties get mutated. And there's a link to the documentation in my repo about render fragments. All right, now let's see this thing in action. I'm going to add a component to the client called Toolbar Razor. And this is how we get access to that AppState cascading parameter. Now you might also think that, wow, this kind of looks like injection. Yeah, it is. It's injection, but using the Blazor component model. And that's the difference. This is the Blazor way to do things. Now you can still use injection if you want to, but this allows us to inject a component. That's a UI component in the render tree. All right, so up here we're simply showing AppState message, got a little bit of style, no big deal, and that's it. So the toolbar's job is just to show what the current value of AppState message is. Now we need to put the toolbar in the UI layout, so let's go to Layout, Main Layout, and instead of showing this across the top, let's show Toolbar. Now we need some code that can mutate that state. So let's go to Home and change that. Okay, so I've just got some text that explains what we're doing here. I've got a button. When I click the button, I'm going to call this Update Message button clicked. And that is simply going to set the message property of AppState to message updated at and then the current time, which includes the seconds. So every time we click on this, the toolbar, which is also handling that AppState, the message is going to update because of this right here. State has changed. So let's do it. Here we go. Initial message because we initialized it. There it is. Boom, boom. So now any component that you have anywhere in your application, just like Toolbar, can access that AppState, show the properties in the UI, and when any other component mutates that state or changes the value of a property, it's going to be reflected in those components. Now, we also have this count, right? And that's because we're going to modify the counter to use that count instead of this current count. Again, we've got our cascading parameter, AppState. And when we increment the count, we say AppState count plus plus, and then we show the AppState count as the current count. Okay, so the toolbar has nothing to do with this. We're just accessing that count, but it's in AppState, so it's outside of the counter page. So if I go to the counter page and I mutate it, change it to like 5 or 6, and then go back home, back to the counter, hey, look at that, it's still 6. So far, we have handled the situation where multiple components that access AppState properties can update their UI whenever one of those components changes those properties. But what if a component needs to take action when a property value changes? For example, the toolbar might want to send a message, make an API call, or the like, not just the toolbar, any component. Well, one option is to handle those things right here in the setters of the properties of the Cascading AppState component. However, that kind of violates the single responsibility principle, and this is really just for state management, right? It's not a place where you should probably put business logic or calling services or anything like that. So what we really want to do is expose some kind of event, some kind of pub subsystem, so that components that access the AppState can get notified when any of these things change. And we'll put those notifications in here. Now, typically this would be done with iNotify property changed. And you could do that. The problem with that is, since it uses standard C# events, you need to handle those events by hooking in the components like counter or toolbar. You need to handle those events and then detach those events when you go out of scope, because you could have memory leaks. So you'd have to then implement the dispose pattern, and we all know how that has worked out in the past. It's kind of a mess. But the good folks at Microsoft have given us another option in the component model for Blazor, and that is an event callback. An event callback is a Blazor-y way to do events. When handling event callbacks, you do not need to implement iDisposable. They're just a nice, clean way to do events without a lot of ceremony. Now, usually you have an event callback type as a parameter. But in this case, we're going to create a list of event callbacks, because if we only had one, then only one client or one component could handle the event callback. Because we want to have multiple components, we need multiple callbacks. All right, so we're also using this state property change args, which is just a record that I've added here that has a property name and an object for the new value. So this does really kind of look like the iNotify property changed argument. Any component that wants to get a callback has to call register callback. And in register callback, we're adding that callback to our list only if it's not already there. Then we want to call notify property changed from our property setters, and we go through each of the callbacks and we ignore any exceptions due to dangling references. In other words, if a component registers itself and then goes out of scope, we'll get an error, but we can just ignore them. So it's an easier way to do things. Now here's how you do it. In the message, for example, we have the state is changed, and then we call notify property changed with the record having message and the value. Message is the property name, value is the new value. We do the same for count. Notify property changed, a new record with count and the value. Now in toolbar, on initialized, we're going to call AppState register callback. And we create the event callback with event callback factory create of state property changed args, and it's this, and here's our handler, handle property changed. So now the toolbar can be notified when any AppState property changes, and we can retrieve the new value. And just for clarity, let's add a couple variables here, just like that. So now let's run this. All right, let's update the message. Boom. We get a breakpoint here. Property name is message. Value, message updated at blah, blah, blah. All right, let's mutate the count. Property name is count. Value equals 1. All right, now let's talk about persisting the application state. And it would be really great if we could save certain AppState properties so that they'll come back and we can reload them the next time the app is run. All right, here's a scenario. You have a large set of input form fields that the user needs to fill out. After meticulously entering 99% of their data, they have to take a phone call, during which the form times out or the computer reboots or some other issue forces them to refresh the page. And all that work is for nothing. By keeping their form values in AppState properties and then persisting those properties to their local storage area in the browser, we can retrieve the values the next time they log in. What's more, we can keep track of other data, such as what page they were using, or any other session-scoped variables that we'd like to persist between sessions. In this example, we'll also implement a time window, after which we will not reload their AppState property values. Another option would be to ask the user if they'd like to continue where they left off whenever they log in. So we're going to need access to local storage, and for this, we're going to use Chris Sainty's Blazor local storage package. So for this, I'm going to go to my CS_proj file and just add the package like that. You can do it however you want, though. So now I'm going to have to modify the program CS file to install Blazor local storage. We'll have to do that in both projects. Next, we're going to separate the properties we want to persist into an interface, and that will allow us to serialize just those properties to JSON. So to the client project, I'm going to add that interface class, AppState.cs. So we've got our message, our count, but I also have this last storage save time. So every time we persist, I'm going to set the storage save time to now. Then when we read it back, we can see how much time has passed and determine whether or not we want to load it. Now, system text JSON will not deserialize to an interface, so we have to create a class that implements the interface, and this one we'll call AppState. So here we go. We have our message, our count, our last storage save time. It's just a simple implementation of AppState. Okay. Now we're going to create a code behind file for Cascading AppState Razor. So I'm going to delete all the code from here and now add Cascading AppState.razor.cs. And here we are. So not only am I inheriting from component base, but I'm also implementing AppState. Now when we save data to local storage and load it back, we need a key. So I have just hard-coded this myAppState key. I also have this storage timeout in seconds that I want to set to 30 seconds. In other words, when we look at the AppState that was saved in local storage and we load it up, we look to see how much time has elapsed. And if it's more than 30 seconds, we don't load it. So now I have a last storage save time here. I'm injecting the Blazor local storage local storage service. Got my child content. Here's my callback. And now whenever a property is set, we do call state has changed, but now we also call save, and we call it asynchronously. And this is a good pattern for calling code asynchronously from a property setter or some other synchronous code. So let's look at save. So we also have this loaded, and that gets set after the first render, because we don't want to try accessing JavaScript, which is essentially what this is, until after the first render. So if we're not loaded, return. Otherwise, we get the date time now. We set that last storage save time, and then we pull out a variable that is an AppState. So that is my AppState component, this, but it only has the public members that are in the AppState interface. And then I'm calling await local storage set item async, the storage key, and the state. Now we also, on after render async, after the first render, call load. Now load does some cool stuff here. We call the local storage get item as string, which returns the JSON string. And if that's null or the length is 0, we're getting out of here. Otherwise, we deserialize that to an AppState variable, and now we've got it. So if the state is not null, we check the time, see how much time has elapsed. And if we're within that time window, we can either set properties manually, like this, and that's fine, but then every time you add a property, you have to modify this code. Another way to do it is to use reflection. You like that? Or you could use reflection. So what I'm doing is I'm getting the AppState as a type, and I'm looking at all the properties on the type AppState. And then for each one of these, except for last storage save time, I'm getting the value, and I'm setting the value of my object, my AppState object, to the value in that state object. Okay? So this little code right here effectively sets the values of our AppState to whatever is saved in local storage. All right, so let's run it. Now remember, that save method that saves the entire AppState, well, all the properties in the interface, to local storage gets called anytime anyone mutates the state. So right here when I do update message, forgot to take that breakpoint off. Okay, we've mutated the state. We've saved AppState to local storage. Same here. Let's do the counter. 1, 2, 3. Now I'm going to change this message again and quickly, within 30 seconds, load it up again. There you go. Message is updated, and the counter is set at 3. Now, if we save and come back after 30 seconds have elapsed, now you can see that state does not show because of that 30-second time window. So everything's back to the way it was. Now here's the deal. The AppState interface and the AppState class determine which properties get persisted, and you can modify them at will. The only requirement is that the properties must be implemented in Cascading AppState Razor. So try it. And that is my demo. Now back to you in the studio, Carl. Now I know I mentioned this before, but I've created 3 versions of this repo for the different render modes. Here I showed the WebAssembly version today. But I've also created a repo for the server render mode and one for auto render mode. And don't forget to check out the Blazor puzzle. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a train!